My name is Roger Rosenberg, and I am a professor of neurology at the University of Texas, Southwestern Medical Center here in Dallas. And I've been a member of the Department of Neurology now at UT Southwestern for 37 years. And I direct the Alzheimer's Disease Center at the medical school, which is funded by the National Institutes of Health. Things look very positive, and I'm very excited about what's happening. And I think it is because of advances that are being made in genetics and genomics. And by genetics, of course, I believe, and my colleagues believe, that Alzheimer's disease is a genetic disorder, that we inherit a risk for it from our parents and from our ancestors. And by genomics, I'm referring, of course, to all of the genes that we have and all of the DNA that we have and all of our chromosomes in every cell in our body. And the DNA is the same in every cell in our body, but it's transcribed differently to make different cells of a specific type and function. So following up on that, we are now analyzing the whole genome, all of the 22,000 genes we have, plus all of the non-coding areas of our DNA, which is the majority, and we're looking for variations. We're looking for variations in our genes. We call that polymorphisms. More technically, we refer to it as single nucleotide polymorphisms because our DNA is made up of nucleotides. And there have been published now some 660 analyses of the total genome variations in persons who have Alzheimer's disease or in their family, and control individuals who do not have it or do not have it in their family, and their differences. There are genes in Alzheimer persons that have variations that are a different population than what one sees in the normal population. And we're beginning to identify some of these genes in terms of what they code for, what proteins are coded for by these genes, and therefore potential variations in the expression of these proteins. Are they increased or decreased? And so we're looking for a pattern of differential expression of genes in Alzheimer's disease. That's very new and that's very positive because these are molecular targets for potential therapies.